Hello, welcome to my channel. I am Ameya and we are discussing about control systems, in which today we are going to discuss very important topic, that is your S-plane. Now S-plane is having very much importance in understanding your control systems because most of the graphical methods are based on your S-plane. Okay, like root locus is based on S-plane. So S-plane is basically a graphical technique or representation of your system into 2D plane, which is much more user friendly to understand the performance behavior of your system. Okay, so S-plane helps you to understand your performance of the system. Once you plot your system on S-plane, you can easily understand and comment on various factors of your controlling system: behavior, stability, performance. Those all things you can discuss just by plotting your system on your S-plane. Okay, so S-plane is having basically two axes. We will just plot that. The real axis is called sigma, and the imaginary axis, vertical axis, is called j omega. Sigma and j omega. And like any the normal 2D plane, this is the negative side. Sorry, I made that mistake. Just a second. This is negative side, that is negative sigma, positive sigma, and there is j omega and negative j omega, like a normal plane. Now, where do you get these values of sigma and j omega? Those are basically roots of your standard equation. Okay, so your control system depends on, if it is a first order system, that depends on tau, and that tau can be easily found out from the poles. And for second order system, that depends on your zeta and omega n, which again reflects into poles and zeros. And because of this second order systems, your poles and zeros are polynomial equations, and that can have sigma plus j omega, that is real values plus imaginary values. So 2D plane basically gives all the possible availability to plot all the possible values of your poles and zeros. So if it is a real, it will be on the horizontal axis. If it is imaginary, it can be on the vertical axis. And if it is combination of real plus imaginary, it can be somewhere here also. Okay, so that's why we basically use S-plane to plot behavior of your system. Then about the representation, poles will be represented on your system as X. Okay, so cross is the representation of poles on your system, and hollow circle is the representation of zeros on your system. Okay, so once you find the values of poles and zeros, you can easily plot those poles and zeros depending upon their values on your S-plane. Okay, positive, negative, depending upon the value. Then there comes the most important factor, that is stability. S-plane will directly comment on stability of your system. Once you plot these poles and zeros, you can easily comment on stability. So there are three types of stability in your system. One, your system can be stable, so that region is on your left hand side. So if all of your poles are on left hand side, you can say your system is going to be stable. The next is unstable. If all poles or any one of the poles is on right hand side of your S-plane, your system is going to be unstable. Now, once you plot poles and zeros, if there is any pole on zero on right hand side, that system is going to be unstable somewhere. So we design our control system so that we can convert that system into unstable system to the stable system. So that is how S-plane helps you to understand and design a control so that system becomes stable. And the middle part is called partially stable. Partially stable is basically on your imaginary axis, The system, if your poles and zeros lies on imaginary axis, those are called partially stable system, and these systems can behave sometimes stable, can behave sometimes unstable. It is unpredictable behavior of your system. So that is also one part of a system, that is partially stable system. So once you plot those poles and zeros, or once you plot your system on your S plane, you can easily comment on the stability of a system. If it is stable, it will be on left hand side. If it is unstable, it will be on the right hand side. And if it is partially stable, there are some poles and zeros on the vertical axis of your S plane. This is the simple understanding of your S plane. Now in next video, what we will talk about is how we can understand the performance or behavior of a system depending upon various factors of tau, zeta, and how we can understand those performance from the S plane. That is importance of your S plane, that we'll be discussing in the coming video. So if you like this content, do subscribe my channel, share it with your friends, and check the profile playlist which is available on my channel for control systems and other subjects like mechanical measurements and industrial automation. Thank you for joining.